Good day everybody and welcome to my channel. My name is Konyede Olodu and today we'll be talking about how to design Raft foundation. How to design Raft foundation. Why do we normally use Raft foundation in design? Basically two things. One, if your soil capacity is not too good, if the soil capacity is not too good for it to be carried on pad foundation, then you can introduce Raft foundation. Or if you have very high loads coming on the foundation, maybe your floor, you are doing an high-rise building, so you will need a Raft foundation to take care of it. Two things, that is it. Number one is if your soil capacity is not too good, and two, if you are designing high-rise or buildings that have high column loads, then you will be advised to use Raft foundation for that design. So once again, if you've not subscribed to our channel, I would like you to subscribe, like our channel and share the channel. And if you have any other structural designs that you want us to talk about, please put it on the comment section, and our subsequent videos we will look into it to teach them. So welcome once again, and we dive in straight into our lecture, into the training. So when you want to do Raft foundation using protastructure, it's the same sequence in our subsequent video, the videos that we've posted earlier, how to design reinforced concrete design. It's still the same process. So we are not going to dwell much on the superstructure. We'll just run through it and we dive straight into the substructure where the foundation will be. So to start, you just click new project and we'll say you name the project Raft foundation, because it can't give space. You can't give space, so we say we make it dash Raft foundation. Raft foundation. That's the first thing. You create your project. Okay, you click UK PS8110 import and you wait. So now this page will come up. So what do? Two things we'll discuss about importing from AutoCAD. If your drawings have been done in AutoCAD, you can import from AutoCAD. So you can look that up in our other videos, how to import from AutoCAD to protastructure. For this, we are going to do a very simple structure just to explain how you can design a Raft foundation. So we'll go straight to octagonal axis generator. The number one thing you need in protastructure is your axis line. I cannot emphasize that enough. Your axis line is very, very important. So that's why we are doing that. First, we click on this. So it will give us an axis spacing of 5 meters at 3 intervals. So but what we want to do, let's do 4 meters at an interval. We say 4 meters at 3 intervals. We say okay. You click OK and it automatically generates it for you. The next thing you need to generate after your column, your axis, is your column. Now let's say we are doing 230 by 230 for a start. If it fails, then we can change it to a bigger columns, but let's start with 230 by 230, 230 by 230, 230 by 230. That is what we will do. So with this, we are done with our columns. The next thing to do after this is your beam. We say beam, we are doing 230 by 450 by 450. We can do this, yeah. Yeah, just do that. Be very fast about it, and we're done. The next thing you need to do is your slab load. We say we are doing 150 thick slab. You go to load and click on room for the dead load we are using. While for the live load, let's say we are using office 2.5 for office general use. So we click on it. Save your work. Save our work. Okay, now we are here. We can either do two things right now. Either we introduce the wall loads before generating other floors. So let's just do that on a quick one. You right click, go to edit beam wall loads, edit beam wall loads, and we say our wall loads to be 3.47, height, our wall height 2.7, and our wall thickness 0.23. We say okay, and click copy beam wall load, and you paste it on it. Paste, copy, yes, you say yes. So with this now we'll finish a floor, but it's just a floor, so we need to create the subsequent floors. Now we'll go to building setup, go to insert story. Here people have been asking me that why am I adding one more floor to it. That one floor, let's assume we have 5 floors, but protastructure sees the roof as another floor. So instead of putting 5, which is a number of floor, you must add the roof, making it 6 floor. We say okay, and you say yes. So automatically it has generated the floors. This story 0 is our foundation level. This is the first floor, second floor, third floor, fourth floor, fifth floor. Why this sixth floor is the roof. So we need to generate this member on other floors. But the trick is, if you are here, you need to go back to where you've already defined the floor, which is on the first floor. We've already defined it. Go back to building setup, generate story. From here now, from the source, we can now get it to all the other floors. Let's assume they are all similar. So if you hold down your shift button and click, you will get up. I didn't put on this last one because I didn't put on this last one, but I will show you what to do with the roof floor now. Just look at it. Now we've generated from 1, first floor, second floor, third floor, fourth floor, and the fifth floor. First, second, third, fourth, fifth. While our roof level is still empty. So what do? Let's click on the fifth floor and go back to building setup we say generate, and we come to this, but we need to take out all the slab, no slab load, no slab, leaving just our beam and wall loads there, and you say okay. But the trick in designing, so many people have asked me about how to design the roof, the roof floor, the roof load. Protastructure doesn't provide you with roof load. So what we do is like this. Now let's delete all beam wall load. Yes, delete beam wall load. Now we can still change all this to instead of we making it 230 by 450, we can make it 230 by 300. So with this, your roof load, your roof beam will be different. If you look at it, we've changed all the roof beam to 300. Okay, what do we do next? Normally, since protastructure does not provide you with the roof load, you create a wall load on your roof beam, edit beam wall load, and you make the unit weights just one, the height of wall 1, and we make the width 0.23. So if you do that, you'll be getting a dead load of just 1 kilonewton as the load on your roof beam. So which is a bit closer, a little bit close to, if you design manually, what you get as your roof load. So this is how we design for roof on protastructure. So copy it out, copy this and paste in all. You say paste copy wall load. So this is how you load your roof. So with this now, we can go to view, right click, look at the 3D. So this is the assumption of how you load the roof and everything on it. Good. So let's go back to our plan. So now we've done this, the next thing we need to do is to run analysis. The first thing we do, this is very important, please pay attention to this. We say you click on analysis, building analysis, come to load combination. Pay attention, this is very, very important. And also, if you've not subscribed to our channel, please just click the subscribe button and also click on the bell so that anytime we put up a new video, you can get notification immediately. So as I was saying, pay attention to this. This part is very important in designing Raft foundation. So click on load generator, then click this, pay attention, create on factor G plus Q combination. This is very, very important. I can't emphasize this enough. It is very, very important. So pay attention. If it's on check, please check it. Then you say okay, and it will generate all the loads combination for you. You said okay, then you can close here. We'll go back to analysis, load decomposition. Load decomposition. We click on this. Sorry, not this. We click on bash. So we click on bash. We click on bash, a bash load, and we say okay, so that it will do all the calculation at once instead of we doing one after the other. With this bash fe finite elements chase down method, it will do all your analysis of the slab immediately all at once, which is very very good. Okay, it has finished doing all the design. You close your structure, apply to all beam in model. So we've done the analysis. We'll go back to building analysis. So with that, we come to edit material. So for our edit material, our column load, the column reinforcement that we'll be using will just be 16, 20, 25. We are not using 32. We say okay. The grade of concrete is C20/25, which is okay. The grade of steel is grade 410 type 2, which is okay, and the diameter is what we are changing. For the beam, we change to just Y16, Y20, Y25, and 32. We are not using that. For slab, we'll be using just Y12, for our slab. Then the links will be using just Y10, and that is what we do. We say okay, but no, this is for the substructure. Why for the roof? The roof we could use 16, we could use 12, we could use 16, we could use 20, 25, but not 32. So that is what we will do. That is what we do. Okay, after that you close up and we move to analysis. So we are doing column and beam. So you say run or start, and you give it time to analyze the whole structure. Just give it time to analyze the structure. Okay, it has finished analysis. You said okay, and we close. So with this now, we've done our design for the substructure. Now we are going to the foundation. Two things we can do. Normally how I do my foundation design, I do it, I click on this active window settings and virtual interrogation, and I go to column display. I click on axis load, and I will click on this. Just click on different combinations so that it will show you the column loads. With this column load now, you know how heavy your loads are. So with this is what the column load is showing. So depending on your loading now, but we are designing for Raft foundation. So once you've gotten to this point, okay, so we are going to do something here. If we are to do a pad design, all we need to do here is just to right click on insert pad base, then it will bring up all this depending on your reinforcement. depending on the reinforcement, let's say 200, everything is like this. You say calculate. Once it calculates, it will show you if this thing shows red, it means you either increase the, so if it shows you anything that shows you red, it means it fails. So it may either fail due to the reinforcement not being enough, or the size is not enough. So you can either increase the size. So we've increased it to 2.4 by 2.4 and it is okay now. So you said okay and you click okay, so automatically it will do that for you. But what we are having here is 2.4 by 2.4, and if we do more of them, if we do more of it, other floors, is still showing us same thing, that even at 2.6, it's still showing you that it is still not enough. So at 4.3 meter by 4.3 meter, that's when, and at y16 at spacing of 75, that is when it passed. So on looking at this width, if you look at this part and this part, it is becoming uneconomical. It is not economical at all to use pad in cases like this. So it's advisable that when you are getting extremely large pads, is for you to do Raft to take care of it, because with this is not economical at all. So I'm just doing this just to show you when not to use pads and for us to use Raft. So I will delete this and we'll do our Raft. So there are two types of Raft. We have the beam and slab Raft, or just the slab Raft. So but majorly we will do, for economic reason, the beam and slab Raft is much more economical than just doing slab Raft like that, because of the depth of the slab that we will be using. So but if you do a beam, the slab thickness becomes smaller. So let's go to beam, and we can do our beam as 230 by let's try 1.2 meter beam. So we go ahead and we do this. We go ahead, we do this. Okay, so there's something I would like us to know in terms of beam design, this Raft design. When you are designing your Raft, what you should pay attention to is your slab, your Raft slab. You must design it not to fail. That is where you are most interested in. You either increase the slab if it's fair. This 150 may not work, so let's start with let's say 250 for a start. So we do 250 slab on it. We do 50 slab on it. Good. Okay, 250 slab on it. Okay, everything is okay. So we've done that. And two ways, we can either input wall load there, or we can even put wall load on, depending on where the wall loads are. But you need to check on your architectural drawing to see where the wall loads are for you to input. So if we've done this, save your work. So the work has been saved. So the next thing you need to do is to come to this strip. Very important. Click on it. You go to FE. You go to FE. On your strip, go to FE on your strip. Okay, go to your strip, slab strip, go to, on getting here, this type, change it to FE strip, finite element strip. And what we'll be using, we can either use this or this. We can either use this or this. This is for, we can either use this too. And mind you, for your this x direction, you draw on this direction. You draw on this direction on your x axis. So this takes a portion of it to cuts a strip in terms of it takes it at least a meter strip. So you go back, change it to y, and we cut through it here. Cut through it. Cut through it. Good. So once we've done this, we save our work again, and we come to this finite element Raft foundation analysis. You click on it, or depending, you can either come here or here, depending on the one that is good for, or you think is easy for you. So these are subgrade coefficients. You need to check your soil report to know the exact coefficient here, but if not, we can leave it at this. So we click Raft foundation mesh analysis for it to analyze it. Okay, we say generate model. It has generated our model. We can close it and just give it time to run the analysis. Good, it has run our analysis. Depending on your soil tests, if the soil test bearing capacity is 200, put it, or whatever it is here, you put it here. We need this, it is very important, so we put it there. So we go to analyze post process, analyze post process, and we are here. This is it. So if you look at this, this is showing you the displacement based on the load on it. So but if we click this, it will make it come this way. So this is the displacement, but the thing we'll be looking at, all this thing shows the different, if you want the bending moments, if you click here, it will change whatever we need. But presently, this is the thing we are looking for first in soil, and this reinforced Raft foundation design, your soil pressure. This is what we are looking at, your soil pressure. You click on it, then come to these load cases, the load combination that we talked about, this G plus Q, because what we design foundation with is the service load on the structure, which is this. So we click on it, So what this thing shows you, this is where you pay attention to. You pay attention to this while designing your Raft foundation. Our soil capacity, the bearing capacity says 200. So but majority of this structure pass, and they are within 50 kilonewton per meter square. So your Raft is okay, just some little points that got up to this thing. So based on what you are saying, your soil, your Raft design is okay. But if majority of these places is showing red, then you know you either need to increase the slab or change the increase the reinforcement and things like that. So this is the first thing you need to check for, that yes, it passed. The other thing you can check for are your moments, the required reinforcement. Is the required reinforcement. Whatever thing you need, this is where you check for. So once you are done with this you close, then it will tell you if you transfer slab strip. You say okay, it will transfer it. Just give it time to transfer. Okay, you close. So once you get to this point, you come to arrange steel bar. If you click on update steel bar, it automatically do the design for you. These are the designs: Y12 at 100, Y12 at 150. So these are the reinforcements that for the Raft slab, But if you need for the Raft beam, you come to foundation, you come to concrete design, come to beam reinforcement design, the story design, read, and foundation beam. So it's when you get here, it shows you not design, but you can either do a bash design, and it designs all check beam, or it selects all beam, and you say calculate. It will automatically do the design for you. So this is the design that it has done. So what you just need to do is to do this one after the other. So it shows you the reinforcement for your design. So this is your design. So this is the design for your foundation beam. This is for your foundation slab. So with this, you have done your design for your Raft foundation. So if there's any question, please feel free to send it via the comment section. We'll be glad to answer you. And once again, thank you for listening, and subscribe if you've still not subscribed, so that you can get more quality videos like this. Thank you, and God bless you. Bye.